Morning, guys. Morning. Morning, guys. Let me just turn the music off. Kyle, Kelly, can you change your name so that it's your first and last name, please? I know that's silly and tedious, but you just have to have your name first and last, so I think you can edit it, dude. If you can't edit it, let me know. Morning. Morning, guys. Let me take attendance. Okay, so I have a question for you guys. So today and tomorrow, So today and tomorrow, before the end of the day tomorrow, we have to have two things done. Lesson 3 and the knowledge check. So I want to sort of pose it as a question to you guys because you guys do have. Let me just pose the two options because we have an IAB and an SRI in ELA and in science. So you're taking an IAB in science today, and you're taking an SRI, which I think is like a reading level test in English today. So with that in mind, you have two tests that you're going to be doing. Would you guys rather do a lesson today, or would you rather do your knowledge check?
Lesson.
Okay, hands up for a knowledge check.
Oh.
Lots of friends, okay? 1, 2, 3, 4, 5, 6. Well, it's got to get done. So, and I'm trying to be democratic about it. And we got to really try to keep ourselves in check. Okay? Because I'm giving an option. I could have just said we're doing this, and I hate doing that. So, let's 7. So friends at home, would you guys rather be doing a knowledge check today, or would you rather be doing a lesson? Okay. Okay, so lesson. Friends in here that would rather do a lesson today. 1, 2, 3, 4, 5, 6, 7. So we're currently tied. Let me see if anybody else. I need someone at home to tell me. Cindy, what would you rather do today, a lesson or a knowledge check? We're tied right now. Ty will go to the lesson. So, Cindy, you don't have any opinion? Okay, Cindy said she wants to do a knowledge check. So what I'm going to have you guys do, listen, this is what we're going to do. We're going to spend 20 minutes on the knowledge check today, and then we're going to jump into the lesson. Okay, so it's not going to be the whole period. So we're going to take 20 minutes for the knowledge check today. If you don't finish, you still have time, so don't rush. And then we're going to jump in for the last half hour into a lesson. I think that's like a little bit, I think it's a little bit of best of both worlds, Hannah Montana style. Does anybody need paper in here? / pencils? I'm going to come around with paper and pencils. What do you need? What do you want? Paper first. Do you need paper, Connor? Paper, Sandy? Paper. I'm going to come around with pencil in a moment. Paper. Adam, can you paper, please? I'll come around with pencils in a moment. Max, you need So I need everyone to get into Alice, please. You're working on that knowledge check. I'm going to come and check it in about 25 seconds. Everybody will need to be in there, or else we will be going right into the lesson. We're taking 20 minutes for that today. I think it's a good compromise. 20 and 30 for the lesson. Okay, let's check on Alex. This is my favorite song. There we go, my favorite song. Okay. Okay, oh, that's weird. Why is it in a different order? Oh, reports, time, topic, that's what I need. Okay, let me refresh this because it doesn't seem like there are that many people in right now. Oh, because it says Sunday. Change the date range. Starting to yesterday. Boom. Compute. Okay, so I have Connor in, Junior in, John in, Gabe in, Sadie is in, Kyle, Cindy, Max, Adam, Cameron, Ian, Tyler, Gwen, Nassim is in, and Abby Wassa is in. Fantastic. Très fantastique. Thanks, guys. We're going to be working in this until 25 past. 10:25. And then we're going to hardcore last 30 minutes with the lesson. Oh, Avery. Oh, Avery, so sweet. Landon, take your hood off, please. Ah, look at that. Ooh, I like today's lesson. Timer on the board, guys. Da, 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 da. Da, 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 da. Da, 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 da. go. Okay. Very nice, ladies and gentlemen. Let's see. Great job. Very nice. Making sure that we're making progress. Oh, Abby, did you finish your knowledge check? Perfect. Nice job. Everybody's making really great progress. Awesome job, everybody. I'm so proud of you. Thank you for your hard work. Taking another 8 minutes and 34. We're Hannah Montanaing it today. Guys, that's a verb. To Hannah Montana. Best of both worlds. That I turned that into a verb. I appreciate everybody giving this their all. Thank you so much. Anybody needs more paper, let me know. I'm going to stop talking. Gabe, Cindy, Max, Sadie, Kyle, Adam, Cameron, Ian, Tyler, Connie Gwen, Sam, and Abby. Oh, I'm going to change Kyle's. I'm going to just change your name because I know some teachers like you have to have first and last name. So I'll just do that for you over on my side. Oh no, that's not what I wanted to do. Oh man, that's awkward. Sorry, Kyle. I meant to rename you. There we go. go, sweetie. Actually, I'm gonna go like this. Perfect. Taking another 5 minutes and 50. I love how hard everyone is working on this. Great job. Okay, we're taking another 3 minutes, my friends. Awesome job. Remember that you don't need to finish this today. We're going to have plenty of time in CCR/in class to
Mrs. Samola, please call extension 3214.
/ maybe Wednesday, because we might need the whole class tomorrow to finish today's. Today's does take the full 55, but we shall see. Okay. Make sure that people are making progress. Awesome work, everybody. Please make sure that you're moving through. Everybody's looking great. I love it. Très fantastique. Sally put it on my desk. Got some nice balloons today. Okay, we're taking another minute. If you'd like to start closing it out and opening up the slideshow, we're going to start on slide number 2, where we are evaluating those exponents. What are they equal to? Remembering back to those exponent operations. Why did I say it in 3 syllables? I don't know. You don't need to like evaluate like the final answer, what it's equal to. I just want you to simplify into 1 power. Okay, very nice. I'm gonna have you guys jump out of that. And let's open up our slideshow for today. Like I said, we will be taking time to finish that later on in the week, probably tomorrow. But I want to jump in and get this lesson started because we will not be able to get this whole lesson done tomorrow. So I am going to check the chat. Yes, we're doing the lesson. So I want you to close out of Alex. And I want you to open up the lesson in the slideshow that is on the screen here. So we're looking at lesson number 3, where we are looking at and representing exponential growth. So now we're going to be looking at some data tables. We're going to be creating some data in these tables, given a scenario. We've done that similarly. We're going to be looking at and making some graphs, some scatter plots. So let's take a look at and let's get started with this warm up on slide number 2. Where it says rewrite each expression as a power of 2. So what's the new exponent going to be using those exponent rules? I want you to take 1 minute right now to complete this one because 1 minute should totally be enough because we did a lot of work with exponent rules here. Okay? Thank you everybody for your hard work. I appreciate everybody's awesome work. Okay, we're taking another 17 seconds, guys. Remember, friends at home can throw questions/answers in the chat. I do have it pulled up now. And we're going to get started. Oh, I do have, I just wasn't sure where the box was. There we go. Okay, take 10 more seconds to wrap up those thoughts, please. Wonderful, wonderful, wonderful. Okay, so this first one, let's review our multiplication rules. When we have exponents that have the same base and we're multiplying them, what do we have to do? There's 2 parts to our rule. Max.
You have to add the exponents.
Add the exponent numbers. Very good. So then what would our new exponent be for the first one? 7. 3 plus 4 is 7. Very good. And then we do what with our base? The base stays the same. Very good. So when we're multiplying exponents with the same base, we keep the base and then we add the exponents. So then what would that second one be? The second one's a little bit of a trickster. What did we get for that second one? What's a new exponent value? Sadie, what'd you get? 2 to the 5th. Okay, what do we think? Junior.
6.
Why is it to the 6th?
Because the second 2, it doesn't have an exponent, but it's covers all 1.
Good, because we got to remember that if we have a number that's just by itself, that's like saying to the first power. So then when we add them, our new exponent 5 plus 1 is going to get me 6. Very good. This is the reason that we're going through these rules, because sometimes we forget those little pieces with like our unknown, when it's implied values. Very good. So then when we're dividing, what do we do when we divide them? We do what to the base? Keep the base the same. Very good. And then what do we do to the exponents? John.
You
You subtract them, very good. And so when we do 10 minus 7, we get, what was it? 3, very good, team. It's gonna be an exponent of 3. Awesome job. This one is a trickster, just like the second one, in the way that we have a 2, that's just a 2. So what are we gonna get as an exponent for this last one here? 8, very good, because it is an implied what on that second and that 2 that just is a 2? An implied 1, very good. So then when you subtract them, you get 8. Awesome job, everybody. Nice job. Very, very good. Wonderful, wonderful. Let's take a look at the next piece here. Okay, we're going to look at our learning targets. Our learning targets for moving forward from what we were doing the other day. We're adding on, making it a little bit more challenging. Number 1, I can explain the connections between an equation and a graph that represents exponential growth. So before we were just looking at expressions, like what would we have to do to get that final answer? Now we're going to be writing actual equations where we're going to have 2 variables. Y is equal to something x, something to the x power. Number 2 is I can write and interpret an equation that represents exponential growth. So these are actually going to be happening in reverse order. So we're going to be creating equations first, and then we're going to be looking at and creating graphs that connect to those equations. Okay. So like I said, we're not going to get through all of this today, and that's perfectly fine. We're going to get through as much as we can while taking our time. So we're going to start today with this first activity here, which should be a nice review because we did talk about exponents to the 0 power in that little mini unit. So we should have a pretty good idea, sorry about that, a pretty good idea of what x to the 0 means or what it's equal to. Today we're really going to be jumping into the y behind it, okay? So what I want you to do is I want you to complete the table, take advantage of any pattern that you notice. So now what I want you to do is I want you to take a minute and a half right now. A minute and a half right now to look at this table, fill in your missing values here. Keeping, so x is equal to 4, 3, 2, 1, and 0. You're going to be plugging these x values in for x in the second line here and calculating what they're equal to. You might need a calculator. And then you're telling me one thing that you noticed or a few things that you noticed about this data. We're down to about a minute. Take 1 minute to fill in this table and get started. Sorry about that, guys. I didn't make that noise. Ooh, nice job, Gabe. On both of those, very good. Oh, and Kyle Kelly, very nice. I like those bullets, guys. Came out cool. Okay, we're taking another 17. I'm going to give you a few seconds at the tail end to firm up those thoughts. Probably won't need your calculators for this one. Take a few seconds to firm up those thoughts. Okay. So if we're looking at this empty box down here, this is like saying 3 to the what power? 3 to the second power. Very good. And then we would say that is equal to what? 9. This next one is going to be equal to what exponent when I rewrite it? 3 to the, oh, that would be next, that would be this one here. 3 to the third would be here, but I'm looking here. 3 to the first, very good, which is equal to 3, very good. And then we have 3 to the 0. We talked about this rule before. 3 to the 0 is always equal to not 0. 1, 3, 2, or any number to the 0 power is equal to the number 1. It's equal to the number 1. That's why I need you guys to use your calculators, because sometimes you forget that rule, and if you don't know it off the top of your head, I don't want you to just say 0 because it's not going to be equal to 0. So remember to use those calculators if you need them. What was one thing that you noticed about this data here? Junior, and then Connor, go ahead, Junior. Divide by 3. As you move in what direction? To the right in your table. Good. So as you move right in your table, you're dividing by 3 every time. Very good. Very good, very good, very good. So now we see why 3 to the 0 isn't equal to 1. Or isn't equal to 0, it's equal to 1. Because we're dividing by 3 every time. So when you do 3 divided by 3, it's not equal to 0, it's equal to 1. Any number divided by itself is equal to 1. Good. Nice job, guys. What else did you notice, Connor? Multiples of 3. Good. Did anybody else notice anything about this data that they got? Gwen? Decrease at a constant rate by a common what? It doesn't have a common difference, it has a common factor. Good. Decreases by a common, and I want us to write factor instead of because factor indicates we're doing what? Multiplying or dividing. Good. Very good. It's decreasing by a common factor. Does anybody else notice anything about this data here? Max?
Yeah, because that's non-linear and it's instead exponential.
Non-linear, very good. Great, fantastic, very good. Let's get some of these things written down. There's a lot of really great things that we noticed here. Awesome job, everybody. Did anybody else notice anything else? Wasn't really expecting anybody to notice anything else, but if you have something that you know, other than that, really great job, guys. Really impressed. Notice some really great things. Very good. I'm going to leave this up for another 15 because I think people are still writing. So I want to make sure that everybody has a chance to. Interesting. Okay, very nice. Actually, super duper duper impressed. Actually, super duper impressed. So now let's take a look here. So here are some equations. Find the solution to each equation using what you know about exponent rules. Be prepared to explain your reasoning. So find these missing exponent numbers, and I want you to be able to explain how you decided that. So I want you to take a minute right now we talked about this before. We're going through it one more time. Give me those 2 missing exponent numbers in A and B. And then on number 2, I want you to tell me 5 to the 0, 2 to the 0. Take a minute and a half right now to do that one for me. I know this one's a little bit easy, but you're just trying it, doing your best. It's giving us a little bit more the why behind it's equal to 1 as opposed to 0. Very nice job, Kyle Kelly. Take another 15 or 5. Really? 5. Okay, so let's take a look at A. I know that we've done sort of things similar to this before. So what would the exponent for A have to be to get a final exponent of 9 to the 7th power? Connor? 0. And 9 to the 0 we know is equal to what? 1. Very good. So it would be like saying 1 times 9 to the 7th is equal to 9 to the 7th. So this is another reason, another explanation as to why, or sort of proof, that when we do 9 or any number to the 0 power, it can't be equal to 0, because then it wouldn't get us that final solution. It would get us a solution of 0, because 0 times anything gets us 0. So when we have any number to the 0 power, it's going to have to be equal to 1 as opposed to 0. What would be my second exponent there in B? 0 again. When you subtract 12 minus 0, 12 minus what gets me 12? 12 minus 0. And if you were to say 9 to the 12, and you were saying, oh, but 9 to the 0 is equal to 0, is that a legitimate fraction? What is that called? If it has a denominator of 0, that fraction is called not determined, undefined. Very good, Junior. It would be undefined. So this is another reason why any number to the 0 can't be equal to 0, because in some cases it would create fractions with denominators of 0, which are undefined. Crazy, right? Very nice. So then what would the 5 to the 0 and the 2 to the 0 be equal to? They're equal to 1. Very good. So this little section, this was supposed to be a sort of a quick activity, because it's just a reminder and it's a little bit of a proof why any number to the 0 power is equal to 1 and not 0. Because if it was equal to 0, it would mess up a lot of things. Okay? So the activity we're going to close with today. I know we still have like 10 more minutes of class, but it's going to take us a little bit of time. Okay? So if we look at slide number 6, we have this like a biology lab, right? So they have 500 bacteria, and they reproduce by splitting. Every hour on the hour, each bacteria splits into 2 bacteria. So what I want you to do with this table, number 1, is I want you to tell me how many bacteria will be in each hour. If each hour they double, that's number 1. Then I want you to write an expression for how you could find the number of bacteria each time. Okay? So I want you to fill in the table here, and then give me an expression for how you can calculate each one of these. I'm going to give you 2 working minutes right now. Right? Oh, yeah, take your time. We still have another minute and a half. And then you're going to write an expression on how you could calculate it. If we need the lights on at any point, let me know, and I can turn them back on. Taking another 36 seconds. Awesome job, guys. Another 10 seconds to firm up those thoughts, please. Awesome job, everybody. So we're doubling our bacteria every hour. So after 1 hour, we are going to have how many bacteria? 1,000, very good. And how did you get that? We can sort of start our expression over here. We did what times what, or what plus what minus what divided by what. Go ahead, Connor. 500 times 2. Very good. Nice job. So that would be the expression to find that first hour. How many are there going to be in the second hour? 2,000. Okay. So then if I want to add on to my expression, how could we have calculated it? 500 times cubed and times 2. Very good. And we're gonna simplify it. I'm gonna show you guys how we're gonna simplify it, but I want to write the expanded expression first. So 500 times 2, then times 2 again. So then hour 3 is gonna have how many bacteria? 4,000. Very good. Nice job. And we can add on to that expression by doing what? Timesing it by 2 again. Very good. Very nice. So, nice job. Oh, that's great. Nice job there, Kyle Kelly. And then hour number 6. This is where it's going to get a little bit trickier. Hour number 6. How many are there going to be after hour 6? 8,000. How many? Well, it would be 500 times 2, 2 times 2 times 2, 1, 2, 3, 4. Very good. It would be 32,000. So 32,000. Or we could say 500 times 2 to the what? How many times did we multiply it? 6. Very good. 500 times 2 to the 6. Very good. And this one would be here, 5,000 or 500 times 2 to the 3rd. 500 times 2. 500 times 2 to the, how many hours? We multiplied it 2 times. That looks nice. Okay, so then our T, this is a general one. This is where we're going to be writing an expression. What are we going to get?
1,000 times 2 to the power of
1,000? What's our base number that we're starting with? 500. Because, and then times, I'm putting a little X for the times, just let me know that we're talking about times. 500 times 2 to the T. Very good. And the reason that we're not doing the 1,000, the reason we're not starting with the 1,000 is because we're saying this would be written as 500 for the 2 hours here. It'd be written as 500 times 2 to the first power, which is equal to 2 to the first power is 2 to the first power is 2. So 500 times 2 to get that first hour. It wouldn't be 5. It would be, if you had done the 1,000, that would be 1,000 times 2, which would get me 2,000, which wouldn't be the correct value. You see why we did 500 instead of because it's how much we started with at hour 0. Very nice. So we're saying 500 times 2 to the t. We start with that start value and we multiply it by whatever we're doing to the number. So we're doubling it. If we're tripling it, it would be 3 to the t. Okay? And the reason that we're multiplying by the 500 at the beginning is because we're not starting at 0, 0. We're starting where? What number are we starting at? 500. So the reason we introduced, remember, if you remember back to day 1, I was talking about it, the parent function is like whatever you're doing to the number to the x power. That's if you're starting at 0, 0. But now because we're starting at 500, we have to multiply by that 500 by whatever you're doing to the x power. Okay, we're throwing in an extra piece because we're not starting at 0 this time, we're starting at 500. So our expression here would be 500 times 2 to the t power. Okay, and that number that comes in front that you're multiplying by the 2 to the t is your start value. Sometimes if you're starting at 0, 0, if you're starting with $0, it would just be 2 to the t. But because we're starting with 500, we're going to have to do 500 times 2 to the t. You guys see the difference there? Because we're starting with a value. Very good. So very nice on that, my friends. So now let's look at the next slide here. We're going to start this. We're going to do these last 2, and then we're going to leave the second half of this lesson for tomorrow. So if we look at slide number 7. No, I clicked on the wrong slide, sorry. Slide number 7, it says write an equation now. We wrote an expression. We need to write an equation relating n, the number of bacteria, to t, the number of hours. So if we want to take that expression and we want to turn it into an equation, we're going to set it equal to something, the variable that we're solving for. So what would our equation look like here? We're adding in this idea of n, total number of bacteria. What would my equation be? What is equal to what?
N equals 500 times 2t.
Very good. N equals, because we're saying the total number of bacteria is equal to, and then that expression that we created in the last piece of this to find out the total number of bacteria. N is equal to 500 times 2 to the x power. The 500 represents what? The starting value in the context of the story, the starting value is the number of germs or bacteria that you start with. Very good. And then the 2 represents what? We're not, yep, so we're doubling it. Good. So it represents the doubling feature of it. If they were splitting into 3, what would your exponent, what would your base be on that exponent? If they were splitting into 3 pieces each, it would be 3. Very good. Because that base tells us what are we doing to our number every time. We're doubling it, so our base is going to be 2. Very good. Timesing it by that initial start value. And you're going to want to, when you write it, you're going to want to put some sort of sign to show that you're multiplying here, just so that the 500 and the 2 are separate from each other. So like you could do the X, I like to do the asterisk most of the time, like the little star. And then now we're going to use this equation to find n when t is equal to 0. What value does the n mean in this situation? So when your t is equal to 0, what would your n be equal to?
500.
Let's plug it in. People are saying 500. Let's prove it. It's time to prove it. You're going to take this equation, you're going to say n is equal to 500 times what? Very good. Times 2 to the 0. We know that 2 to the 0 is what? It's equal to 1. 500 times 1 gets me n. Very good. 500 is equal to n what? Give me a label on it. 500 pickles, pencils, notebooks. Bacteria. Very good. So you can write this down. I'm going to tell you what we're going to be doing tomorrow. Okay. So we were talking about bacteria today that doubled every hour. Tomorrow we're going to be creating a second set of data where the bacteria is going to be tripling every hour. And we're going to answer some questions about that. We're going to create a data table for that scenario. And then, so like that's slide number 8 is there we have a different laboratory where we have this equation. We're going to have to explain what each of these pieces means, and we're going to create some data points. And then, here it comes. This is exciting. We're graphing them. We're not going to be looking at graphs tomorrow. We're going to be creating graphs tomorrow. So we're going to be creating some graphs tomorrow for the 2 different scenarios, the doubling on slide number 9, the tripling on slide number 10, and then we're going to be answering some questions. Okay? Tomorrow's not going to be too bad. I think it's going to be a nice sort of stepping stone from today. We're going to be hitting a different learning target tomorrow, so that'll be fun. For now, you guys have 20 minutes of Alex time due today. So by the end of the day today, you should have 20 minutes in. It's going to be going into Power School, so that means you want to try to get that 20 minutes in. If you completed it during school, like, that's good. So you need to have a total of 20 by the end of the day today. Okay? So we have like 1 minute before Spanish. So if you want to, it's not a big deal, Kyle Kelly. If you want to take a minute to get yourself settled before Spanish, you can do that. You can head out in about 30 seconds. Friends in here can work on their Alex knowledge check if you don't go to Spanish. People at home, if you don't go to Spanish, you can jump onto that Alex knowledge check. And then, yeah, that'll be that. Friends in here can grab their stuff and go to Spanish. Have fun. People at home, you can jump out and go to Spanish. Okay. Yes, sweetheart. Yes, sweetheart. Thank you, sweet. Thank you, sweet.
absolutely not. You ever deal with art? Read a book. Holy shit. Please don't ask for all. Understand. It's 70 out right now. So it's not cold. Cold, I guess. Yeah, cold. My phone's tripping. It won't load. So it's turning its 52. So everything.
Everybody.
What's that?
Perfect. Yeah, no problem, sweetheart. Yes. Yes. now it's your turn, guys. Not half my house. Kyle, you'll get yours when you come back tomorrow, sweetie. Next, Emilio, you have what we want. Okay, please. Okay, take turn. And drinking your coupon. No.
Mr. Ellsworth, please call extension 3214.
Boom. You get 15 for coupon. Coupon. Okay, so 3 points on any assignment. There is a reduced homework and a delete. Or so send a specific email to the person you want to add it to, and then they'll put it on the list, or like the one that goes to the most. Okay, see. Yeah, okay. Did you get in and working on that, please? One, two, oh, sorry. Yeah, repeat your coupon. So you have 3 extra points. And there is reduced homework and late. 3 extra points. I feel like at this point in the year, okay. And any topics? Wait. Wait. Eyeball. Okay, yep, sorry. You get 13 to a coupon. Nice job, everybody. All the best. Moving it up Gary's way. Oh, Mr. Main didn't stop recording.